Watch this glass break. Now watch it come back together. One of these things happens in our universe. The other never does. And here is the strange part. The part that should bother you. The laws of physics don't know the difference. Every fundamental law we have, every equation that describes how atoms move, how forces push, how energy flows, works exactly the same whether time runs forward or backward. To the deepest rules of reality, a glass shattering and a glass unshattering are equally allowed. And yet, you have never, in your entire life, seen a broken glass leap off the floor and make itself whole again. So where does the difference come from? Why does time have a direction at all? Why does the past feel fixed and the future feel open? Why can you remember yesterday, but not tomorrow? The answer is one of the most beautiful ideas in all of science. And by the end of this video, you'll see time itself differently. Let's make the problem sharp, because most people never realize how deep it goes. In physics, there's a property called time symmetry. It means take almost any basic physical process, film it, and play the film backward. And what you see is still a perfectly legal process. Nothing is broken. A planet orbiting a star, played in reverse, is just a planet orbiting the other way. Two billiard balls colliding in reverse is just another valid collision. At the level of individual particles, time has no arrow. It could run either way, and physics wouldn't blink. But step back into the world you actually live in, and time has a screaming, obvious direction. Coffee cools down. It never spontaneously heats back up. Smoke spreads out across a room. It never gathers itself back into a tidy stream. Eggs scramble. They never unscramble. You get older, never younger. Buildings crumble. They do not assemble themselves from rubble. This is the scandal. The microscopic laws say time is a two-way street. The world you live in says it's a one-way road, and there's no going back. For these two facts to both be true, something else has to be going on. Something that doesn't live in the individual particles, but emerges when you put trillions of them together. That something has a name. Entropy. You've probably heard entropy described as disorder. That's the popular definition, and it's not wrong, but it's misleading. Let me give you the version that actually explains time. Entropy is about counting. Imagine a box. On the left, a cluster of fast-moving gas molecules, hot. On the right, nothing. Now let them go. What happens? They spread out, they fill the box. Every time. You know this in your gut. But why? Here's the real reason, and it's pure logic, not mysticism. There is only a tiny number of ways for all the molecules to be packed neatly on the left side. But there is an almost unimaginably huge number of ways for them to be spread evenly across the whole box. So when the molecules move around randomly, bumping and bouncing, they are overwhelmingly likely to end up in one of the many, many spread-out arrangements, simply because there are so many more of them. Not because of a force, because of odds. That's entropy. It's not a substance. It's not a force pushing things. It's a measure of how many ways a system could be arranged and still look the same. Low entropy. Few arrangements, special, rare. High entropy. Countless arrangements, common, overwhelming. And systems drift from rare to common for the same reason a shuffled deck of cards comes out messy. There are just vastly more messy orders than neat ones. This is the second law of thermodynamics, and it's not really a law of force, it's a law of probability. In any closed system, entropy almost always increases, not because it must, but because the alternative is astronomically unlikely. Now, hold that idea, because we're about to connect it to time itself. And this is where it gets beautiful. Go back to the glass. A whole glass is a low entropy arrangement. Its atoms are organized in a very specific, very rare configuration, a shattered glass, shards scattered across the floor, is a high entropy arrangement. There are countless ways to scatter those pieces, and only a vanishingly few ways to assemble them into a standing glass. So when the glass falls and breaks, it moves from a rare arrangement to a common one, from low entropy to high. And that direction, rare to common, ordered to spread out, happens overwhelmingly in one direction. That is the arrow of time. Time's direction is not built into the particles. It's built into the statistics of trillions of particles. The future is simply the direction in which entropy increases. The past is the direction of lower entropy. Forward means toward the more probable. Let that land. The reason you can't unbreak a glass is the same reason a shuffled deck won't sort itself, the same reason coffee won't uncool, the same reason smoke won't gather. It's not that these are forbidden. It's that they are so unlikely that across the entire age of the universe, you would not expect to see one. And here's the part that reframes everything. Your memories work the same way. You remember the past and not the future, because memory is a record, a low entropy imprint left by a higher order past. The arrow in your own mind is the same arrow as the breaking glass. You are made of the second law. But this raises a deeper question, a dangerous one. If entropy always increases, then it was lower yesterday, and lower the day before. Follow that backward far enough, and you're forced into a strange conclusion. If everything is running downhill from order to disorder, then the universe must have started in a state of extraordinarily low entropy, incredibly ordered, incredibly rare. And it did. The early universe, just after the Big Bang, was in one of the most special, low-entropy states imaginable. This is one of the deepest unsolved questions in physics. We can explain why entropy increases going forward. That's just probability. But we cannot fully explain why it was ever so low to begin with. Why did the universe start in such a rare, ordered, improbable state, the very state that gives time its direction? Nobody knows for certain. There are ideas about cosmic inflation, about the nature of gravity, about whether our universe is one of many. But at the center of it all sits this stubborn fact. Every arrow of time you have ever experienced, every memory, every breath, every moment of before and after, traces back to the strange, ordered way the universe began. You feel time move forward because 14 billion years ago, the universe was wound up like a spring, and it has been slowly, irreversibly unwinding ever since. We are living inside that unwinding. We are the unwinding. Sit with what this means. Time is not a river flowing past you. It's not a thing that exists on its own, ticking somewhere out in the universe. Time's direction, the difference between past and future, is a statistical fact about how matter is arranged. Forward is simply the way the odds run. And that means time's arrow is not eternal. The spring is unwinding. One day, unimaginably far away, entropy will reach its maximum. Everything spread out even still. And when there are no more rare arrangements left to lose, when entropy can no longer increase, there will be no more difference between forward and backward. No more change. In a very real sense, time itself will stop having a direction. The arrow you live by, the one that lets you remember, decide, hope, regret, exists only because the universe is still in motion between its ordered birth and its silent end. You are alive in the brief window where time still means something. That's not a sad thought. I think it's the opposite. The arrow of time is the reason anything happens at all. It's the reason you can change something, the reason a moment matters. So, why does time only move forward? Not because the laws demand it. They don't. Time moves forward because the universe began in a rare, ordered state, and everything since has been drifting toward the probable, and that drift, multiplied across every atom in existence, is what we call the passage of time. The next time you watch something break or cool or fade, the next time you feel a moment slip from future into past, remember what you're really watching. You're watching the universe count its way, step by overwhelming step, toward the most likely arrangement. You're watching the spring unwind, and you're watching the one direction that, for now, still carries everything forward. Keep looking up, and keep thinking.